So today's notes, we're covering difference of two squares. This is going to be a little more intro to integrated two, dealing with, again, multiplying binomials. This is going to be a special case. And we also covered classwork finals review number 2. So we're going to be doing this worksheet here in class, and this final review 2, classwork, that's what we're going to turn in for classwork today. And I'm giving you a homework assignment. Homework final review 2, very similar. So we're going to go over how to do this one in class. The other one's going to be for homework. But we're going to start with difference of two squares. I don't need you to submit the notes to me, but you're going to want them in your composition book so you're ready for integrated 2 next year. So the other day we had an intro to integrated 2, diamond problems and multiplying binomials. Okay. Today we're going to be talking about difference of two squares. Okay. Okay, so difference of two squares. Example 1. So we're going to do a little review from the other day, use diamond problems. Okay, so use diamond problems to multiply the following binomials. Okay, so I'm going to go through 3 going across. So the first one, x plus 8, x minus 8. B, a minus 4, a plus 4. C, x plus 3, x minus 3. And again, we're going to be doing diamonds for this. So I'm going to set up my diamonds. And remember, these numbers here are going to go on the side. And the only time I use diamonds is if this is an x and an x, or an a and an a, where there's not another coefficient in front of it. It's not like a 2x or a 3x. It's just plain x, okay, in both of them. Then I can use a diamond. And so I'm going to put 8 and negative 8 on the side. Over here, negative 4 and 4. Over here, 3 and negative 3. And then I'm going to multiply to get the top. So I'm going to get a negative 64. I'm going to add to get the bottom, 0. So when we're doing this, we saw the other day that when I was doing this in a box, okay, we got an x and an x, which is an x squared. So all of these are going to start with an x squared. And then what we saw was we ended up adding our x's. This sum here is going to be our x's. So we have 0x. And then our constant, the number without the x, was the product. So negative 64. Now I'm going to clean this up. And I don't need to write the 0x. This is really x squared minus 64. And that's your answer. Now, what you'll notice is in each of these cases, they're the same terms, but one of them's positive, one of them's negative. Okay, so that's what's going to happen in each of these. So here, when I'm multiplying this, I'm going to get a negative 16 on top, but when I add, I get a 0. So that's going to happen every single time I'm doing these problems. So now in this case, this is going to be an a squared. Again, 0a minus 16. Okay, over here. 3 times negative 3, so that's going to be a negative 9. 3 plus negative 3, 0. So again, I'm going to get x squared, no x's, minus 9. And that is our answer for each of these. Now, remember the title of this was difference of two squares. And let me zoom the other direction. And so when we say difference of two squares, difference in math means minus. So this means I'm minusing two squares. X squared is a square. X is being squared. 64 is 8 squared. So this is a square minus a square. That's why it's called difference of two squares. We're subtracting two squares. Here, a squared minus 16. Again, a is being squared, and this was a 4 being squared. X was being squared, and then my 3 was being squared. So these are differences of two squares. So again, what you'll notice is they have the same terms, in both parentheses, but one's a plus and one's a minus, okay? And so that middle term, which was maybe the x's or over here your a's, was canceling out all the time. So I'm going to write a little formula here. Difference of two squares. And this is when I have x plus some number, I'm just going to call it a, and x minus some number, again a, one of them being positive, one of them being negative. The formula is the following, okay? I don't need to do a box. I don't need to do a diamond. It's going to be the same pattern every single time. So what happened here was we basically squared the first term, x squared, square the second term, 64, and it's a minus between. So I'm going to square the first term, x squared. I'm going to square the second term, a squared, and again, there's a minus in between. And that is our formula for difference of two squares, okay? Now you'll notice all of these were just an x. Well, let's take a look and see what happens if we have a number in front. So in these examples, and actually before we do that, let's try these without doing the diamonds, okay? So now we're going to use the idea of difference of two squares to multiply the following. So again, the other day we were starting with boxes, then I showed you how to do the diamonds. In this case, these are special ones, okay? Where again, you have x in the front, x in the front here, and then one is a plus and the other is a minus of the same thing. Okay, so let's try these. So let's say we have x plus 7, x minus 7. B, m plus 5, m minus 5. And it doesn't matter if you have the plus first and then your minus second or vice versa. So I'm going to do one where it's flipped. So let's say we have the y minus 2 first and then a y plus 2. Okay, again, it doesn't matter as long as one of them is positive and one of them is negative. So instead of doing the diamond, I can just take my first term, square it, take my second term, square it. So I'm just going to physically write it here. So that's really what I'm doing. I'm squaring my x. I'm squaring my 7. And so my answer is x squared minus 49. Okay, now this time I'm not going to write it as a square. I'm just going to square it in my head. So m, I'm going to square that. My 5, I'm going to square that, which is 25. So I get m squared minus 25. Y minus 2, y plus 2, again, square my y. I'm going to square the 2, whether it's positive or negative. When I square it, it's going to become positive, so it's 4. And then remember, it's always a minus because when I'm really multiplying my negative and my positive, I'm going to get a negative. And those are my answers. So the next ones we're going to try, we're going to see what happens if we actually have numbers in front of our x's. Okay, that's going to be our next. So example 3, this time we're going to multiply using the box method. Okay, so you can always use the box method, whether or not it's an x or if it has a 2x or something like that. Where the diamond, it has to be just a plain x. It can't have a number in front of the x. So I'm going to do 2 of these. So let's say we have 8m plus 5 and 8m minus 5. And I have 2x minus 3 and 2x plus 3. So again, you'll notice that they're the same terms, but in one situation, one of them is a plus, one of them is a minus. Here we have a minus and then a plus. So since we have the numbers in front of our x's, we cannot use a diamond. So I'm going to use the box method. And I know how many boxes I need by how many terms I have. I have 2 terms here and 2 terms here, 2 by 2. And it doesn't matter if I do my 8m plus 5 on the top or on the side. Okay, one of them's going to be on the top. The other one's going to be on the side. And then I'm going to multiply this out. 8m times 8m is 64m squared. 8m times 5 is 40m. A negative 5 times 8m is a negative 40m. And a negative 5 times 5 is a negative 25. So again, what you're going to notice happens is the same thing that happened in the other problems. That positive 40m and negative 40m are going to cancel out, so I'm not going to have any m's. And my final answer is going to be 64m squared minus 25. Okay, over here, 2x and minus 3, 2x and plus 3. So I'm going to get 4x squared. 2x times negative 3 is negative 6x. 3 times 2x, 6x. 3 times negative 3, negative 9. And again, I have a positive and I have a negative. So those are going to cancel out. That is always going to happen when they are the same terms with 1 plus, 1 minus, every single time. So I'm going to get 4x squared minus 9. So you'll notice again, we have a square minus a square minus a square. So whether it's just an m plus 5, m minus 5, kind of like the problem we did on the page before where we could use a diamond, or if you have a number in front like this, every single time it ends up being a square minus a square. So I squared this, I get 64m, m squared. I square 5, I get 25, and then you always have a minus. So let's write out again, difference of two squares. This one's going to be a little more generic. Okay, so it may not necessarily be just like x plus x minus. Okay, I'm just going to put an a plus b, a minus b. So I've got some term plus another term, and that same some term minus that same other term. And what's going to happen is, again, I'm going to square the first term, a squared. I'm going to square the second term, b squared, and I have a minus every single time. And that's our formula for difference of two squares. So I'm going to give us 2 of these. Actually, I'll give us 3 of these ones to try, because now that we can do this, it should be rather fast. So example 4, use the idea of difference of two squares to multiply the following. So let's say we have 4x plus 3, 4x minus 3, 7x plus 2, 7x minus 2, and 9x plus 5, 9x minus 5. So again, I don't have to do the box. I see the pattern. So let me just write out for the first one. I'm going to take my 4x and I'm going to square it, minus, and I'm going to take my 3 and I'm going to square it. So when I take 4x and I square it, I get a 16x squared and minus 9. And that's your answer. So for this one, 7x times 7x is 49x squared. Okay, and 2 squared is a minus 4. And we just multiply those binomials together. Now again, understand this is how I do it when you have the same terms, but one's a plus and one's a minus. If these were totally different numbers, I would use a box. If this was a plus and this was a plus, again, I would not use this method. Over here, last one, this is going to be 81x squared because 9 squared is 81 and 5 squared is 25. So 81x squared minus 25. So that's the end of the notes section. we're going to move into the classwork section. So if you want to get your classwork final review number 1 out on your phone or on a tablet, or if you have it and you're just going to do it on a piece of paper. Okay, so this classwork, again, you're going to have homework that's very similar. It's going to be called Homework Final Review Number 2. This is over chapter 2, which is on lines, linear functions. So on the very first problem here, it says for each of the lines of the, given at the right, find the slope and write the equation for each, okay? Now, I'm going to start off with the one that's probably the easiest, which is B, okay? So let me just draw on top of B. Okay, so this one right here is B. Oops. I'm going to zoom in a little bit more. So again, here on B, this one right here, this is the one that I'm going to be looking at right now. And on this one, what you'll notice is we can easily identify our y-intercept. It's right there at 10. Okay. Right there at 10, that's our y-intercept. And then I can look at my slope, okay? And to find your slope, let me just write real quick the little formula for slope here, a little reminder. Let me squeeze it right here. So slope. So slope equals change of y over change of x, or rise over run. So your change of y is your up and down, and your change of x is your left, right, okay? So we need to look for our slope. And let me also jot down here that the equation of a line is y equal mx plus b. Remember, m is your slope and b is your y-intercept. So if I come back to letter B here, or line B, you see my y-intercept is 10. And then if I'm trying to figure out how I'm moving, they've got these little triangles down here. I'm going to zoom in a little bit more for us. So I personally like to think about how am I moving in terms of my y direction first. So I'm going up 3 over 1. So that tells me my slope is going to be 3 over 1 or 3. So I know my slope is 3 and I know my y-intercept is 10. So knowing both of those facts, I know that B is going to be y equal 1x, or even just x, plus 3. Or sorry, plus 10. Okay. Let me try this again. I moved it out of the screen and I lost my numbers. Okay, so my slope is 3. My y-intercept is 10. Try it one more time. Okay, so slope is 3, y-intercept is 10, and that's your equation. Okay, so let's look at the next ones here. So I think probably the next one that's going to be the easiest one to do, and let me just get rid of this. Okay, so we just focus on the line. I think the one that's going to be nice to do next is actually this one right here. Okay, let me get it in a different color. Okay, so this one right here, I think that one's going to be the easiest one for us to do next. And so what you'll notice here is the slope. I'm going up 1 over 1, up 1 over 1, up 1 over 1 each time. So my slope is 1, okay? Now, your y-intercept, if I extend this up, okay, extend my y-intercept up, okay, you see it's going to cross. Now, when I'm counting, let me just get, so I can do this. Okay, so here, I'm at a height of 10. Okay, here, I'm at a height of 11. So I'm just put a dot right here. So here, I'm at a height of 11, and I'm gonna go up 1 over 1, which puts me at 12. And then I'm gonna go up 1 over 1, which puts me at 13. So I'm going to have a y-intercept at 13. and my slope is 1. Okay, and that's D. So y equal 1x plus 13, or just x plus 13. Now, let's take a look at letter C and letter A, okay? Let me start with A. So both A and C, you notice that your y-intercepts are not super nice. We can't tell exactly where they are. And so when I'm looking at this, I'm trying to figure out, well, how am I moving from point to point? I am going down 2 over 5, down 2 over 5. So my slope is going to be a negative 2 over 5. And I don't want to just estimate my y-intercept. So what I'm going to do is I'm just going to grab a point on this line and I'm going to use it to solve. So let's say I use this point here. This is a nice point on my line. And that's at 1 comma negative 6. So I'm going to use 1 comma negative 6, having a slope of negative 2/5. Okay. So let me just kind of jot down my important information. So I know it's going to be y equal negative 2/5 x plus b, because I know my slope is negative 2/5. Now I'm going to be using a point 1 comma negative 6 to figure out what my b is. So I'm going to put 1 in for x and negative 6 in for y. So I'm going to go negative 6 equals negative 2/5 times 1 plus b. And so when I do that, this is just going to be a negative 2/5. So I'm going to get negative 6 equals negative 2/5 plus b. And I can add 2/5 to both sides if I want, okay? I could also fraction, but I think adding 2/5 to the negative 6 isn't going to be that bad. You can also use your calculator if you need. So I'm going to add 2/5 here, so it's gone. I'm going to add 2/5 here. And so that's going to give me negative 5 3/5. Now again, you can put that in your calculator if you need. So my final equation, let me get I'll do it in red, so we can kind of see it through all of this. My final equation is going to be y equal negative 2/5 x minus 5 3/5. And that would be my line. Okay, now on C, I'm going to do a similar idea for C. So let's take a look at C. And let me just get rid of this. Okay, and we're going to focus on C. And when we're doing that, what we'll notice is I'm going up 1 over 2, up 1 over 2, up 1 over 2 every single time. So my slope is going to be up 1 over 2, 1/2. Okay. So you can also think of this as I'm going 1/2 every unit. Okay. Half every unit, a half every unit. So 2 ways we can think about this problem. Okay, it's not crossing nice here, but it did cross nice here. Okay, and so what's happening is I'm going a half every unit. So if I went over 1, I'm a half. If I go over 1 again, I'm a half higher. So if I'm thinking about that as I'm going backwards, and I'm here at 0, and I'm going to be going over 1, down a half. I'm actually at negative 1/2. This one you can do that probably easier with than you can with the 2/5. Okay. So that's going to be y equal, let's get a different color. Okay, y equal 1/2 x minus 1/2. Now, if you have trouble doing that and counting over, if you know your slope is 1/2, because we saw that over there, then do just like I did here, take a point that's on your graph, substitute in for the x and the y. Okay, so I would have had y equal 1/2 x plus b. and then I can solve that. Okay. Now on these next problems, they're asking for us to do these with a table. I'm actually going to just do all these algebraically, okay? So if I know my slope is 3, I know I'm going to have y equal 3x plus some b, some y-intercept. I need to figure out what that needs to be so that when I put in a 2, I get out an 11. So I'm actually going to put 2 in for x and 11 in for y. Okay, 2 in for x and 11 in for y. Okay, so when I do that, and I put my 11 in for y, I get 11 equals 3 times 2 plus b. So 11 equals 6 plus b. I'm going to minus 6 from both sides. So I get 5 is equal to b. And so my equation, 3x plus 5. And that's my equation. Again, I'm going to do a similar idea over here. So I know that my equation is going to be y equal 1/2 x plus b. And I'm going to be putting the 4 in for my x and my 6 in for my y. So I'm going to get 6 equals 1/2 times 4 plus b. So I get 6 is equal to, and when I take 1/2 times 4, I get 2. And I'm going to subtract 2 from both sides, so I get 4 equals b. So my equation is going to be y equal negative 1/2 x plus 4. Okay. Now, the next ones, I definitely would want to do it this method. I would not want to make a table with such big numbers. So that's kind of why I'm running through this method anyways with these problems. So let me focus on this one here. Okay. So I know I'm going to have y equal negative 3x plus b. Again, my 15 is going to go in for my x, my negative 50 for my y. So I get negative 50 is equal to negative 3 times 15 plus b. Negative 50 equals negative 45 plus b. I'm going to add 45 to both sides, so I get negative 5 is equal to b. And my equation, y equal negative 3, because that was my slope, okay, x minus 5. Big numbers, but ended up being a nice equation. Okay, here's even bigger numbers. Let's see what happens over here. Again, same process. So I've got y equals negative 2x plus b. Put 64 for x, 55 for b. So 55 equals negative 2 times 64 plus b. 55 equals negative 128 plus b. And I'm going to add 128 to both sides. So I'm going to go 55 plus 128. And I end up with 183. So I get 183 is equal to b. And so my equation is going to be y equal negative 2x plus 183. Now these ones again are asking us to do a table, okay? I am going to just use algebra in all 4 of these cases. Now how these are different than the last ones we did, the last ones we knew the slope and a point. Here I don't know the slope, but I know 2 points. And if I know 2 points, I can find the slope. So I'm going to find my slope. And let me just remind us that slope is equal to change of y over change of x. And what how we find our change of y without having to plot these is we subtract our two y's. So we're going to call one of them y1, one of them y2. I'm going to write y2 minus y1. Doesn't matter really which one is y2 and which one is y1, because you could rearrange, take this point and have had it listed second. But if I'm doing a point from this second, a y from the second point, I need to do the x from that second point. So I need to have x2 minus x1. So when I'm trying to find the slope, usually I'll try to see if I can do subtraction where maybe I don't have a negative. It just kind of really depends. Okay, so to find my slope here, I'm going to do my change of y over change of x. Now, either I can do a 2 minus a negative 1, or I can do a negative 1 minus 2. I think I'm going to do negative 1 minus 2. And then if I do negative 1 first, minus 2, I have to keep that order. So I have to take 4 minus 1. And I end up getting a negative 3 over 3. Now, I'm going to write this. You don't need to write this, but I want to show you if I had done it with the other y first. So if I had said 2 first, that's fine. Now, where I have to be careful is 2 minus what? Negative 1. A lot of times people go 2 minus 1, but it's 2 minus a negative 1. Okay, so you just have to be careful about that. And so if I did 2 minus a negative 1, I need to do 1 minus 4. And what's going to happen is this becomes 2 plus 1, which is positive 3. This is 1 minus 4, which is negative 3. You see I'm getting the same thing in both cases. And in both cases, this one's a negative 1, and this one's a negative 1. So it didn't matter which direction I went, okay? So let me just get rid of this, and I needed it once. Okay, so now what I'm gonna do is I now have my slope, okay, negative 1. I also have 2 points. Well, I don't need both points, I just need 1 point. So let's choose a point to use. So let's say I choose that point, okay? That's the point I'm going to use. And so I'm gonna use 1 as my x and 2 as my y. So I know I'm going to have y equal negative 1x plus b. And I'm going to put these in for my x and y. So I'm going to get 2 equals negative 1 times 1 plus b. 2 equals negative 1 plus b. I'm going to add 1 to both sides, and I get b equals 3. So my final equation is going to be y equal negative 1x, or just negative x, plus 3. Okay. Okay, so that's how we're going to do these problems. Okay, so the extra step is I need to find the slope first, and then I'm going to choose one of the 2 points. So change of y over change of x. So I think I'm going to do 4 minus 3. And so since I do 4 from here minus 3 from here, I have to do 5 minus 7. And I get 1 over negative 2. So my slope is a negative 1/2. So now I know I have y equal negative 1/2 x plus b. And again, I'm going to figure out which point I want to use. It doesn't really matter. Let's say I use this point. Okay, so I'm going to put 5, 4. So I'm going to get 4 equals negative 1/2. That's a 4. Make sure it looks like a 4, not a y. 4 equals negative 1/2 times 5 plus b. So I get 4 equals negative 5/2 plus b. So at this point, I can fraction best if I want. I could change this to a decimal. Half of 5 is 2.5. Or I can do this on my calculator. Okay, so let's just say I'm going to add 5 halves on my calculator. So I'm going to take 4 plus, because I'm going to add 5 halves. So remember, to get a fraction, you do alpha y equal, and you want number 1, or just enter. okay? And then I can type in my -5/2, and I want to make sure I put in a -5, not -5, because it may not read that. And so I get a 3/2. And actually, sorry, it was a minus. I'm adding it to both sides. So let me re-enter that. And I'm going to get rid of that negative and try it one more time. And I get 13/2. So I'm going to get 13/2 is my b. So my equation is y equal -1/2 x plus 13/2. Okay, now the next ones, again, these ones are the ones that said use algebra. That's what we have been doing. These ones have bigger numbers. It's the same process. Don't let the numbers scare you. So I'm going to do change of y over change of x. I think I'm going to do 68 minus 67. And if I do 68 minus 67, I need to do 50 minus 55. So I get 1 over -5, so a -1/5. So I'm going to have y equals -1/5 x plus b. And again, I need to figure out which point to do. I think I'm going to do the 50, 68, okay? So I'm going to put 68 in for y, 50 in for x. And when I take -1/5 times 50, that's actually going to be nice. If I put that in my calculator, I get a -10 plus b. I'm going to add 10 to both sides, so I get 78 is equal to b. So my equation is going to be y equal -1/5 x plus 78. The next one. So on this one, change of y over change of x. I probably would do 278 minus 168. And then all my x's, I'm going to have to do 57 minus 35. And when I do that, I get a 110 over 22. And if I put 110 divided by 22 in my calculator, I actually get 5. So I have y equal 5x plus b. And then I need to figure out which point I would prefer to do. I'm leaning towards this one, okay? Again, it doesn't matter. So 168 is equal to 5 times 35 plus b. So let's see, 5 times 35. 5 times 35 is 175. So I'm going to get a 168 is equal to 175 plus b. I'm going to be subtracting 175 from both sides, okay? I'm going to go 168 minus 175, and I get a -7. So -7 is equal to b. So my equation is y equal 5x minus 7. Nice simple equation for those big numbers that we have. Okay, and then the last section of this is the big race, the tricycle race problems, okay? Okay, so the big race, heat one. In the first heat, Leslie, Kristen, and Evie rode by tricycles toward the finish line. Leslie began at the starting line and rode at a constant rate of 3 meters per second. Okay, so Leslie began at the starting line and rode at a constant rate of 3 meters per second. Then we have Kristen. Kristen got a 6-meter head start and rode 2 meters every 5 seconds. And then Evie rode 5 meters, oops, that's not gonna be helpful. 5 meters every 4 seconds and got an 8-meter head start. Okay, so I've got 3 people. I put them each in a different color, and I'm gonna write an equation for each of them. So I'm gonna start with Leslie, and I'm gonna color code. So Leslie, y equal, started at the starting line. So she started at 0. And then she rode a constant rate of 3 meters every 1 second, so plus 3x. Or you can also just say y equals 0 plus 3x, or just y equal 3x. Now, Kristen got a 6-meter head start. So for her, I'm going to go y equal 6-meter head start, and she rode 2 meters every 5 seconds. 2 meters every 5 seconds. And Evie rode 5 meters every 4 seconds and got a 8-meter head start. Oops, 8-meter head start. So y equal 8-meter head start, and she did 5 meters every 4 seconds. Okay. Now, when we graph these, the x-axis is our seconds, the y-axis is our meters. So let me get that on the screen. Okay, so I scale this, okay. I just, going by ones, but I just marked 5, 10, 15, and this is my seconds. Again, do the same here, 5, 10, going by ones. This is meters. And I'm gonna plot each of these in a different color. So I'm gonna do Leslie in my purple. And then if you don't have colors, then put an L by hers, a K by Kristen, and E by Evie, so you know which one's which. Okay, so I'm starting at, just, I'm starting at 0. Okay, and I'm going 3 meters every 1 second, 1, 2, 3 every 1. We want to be accurate with this. So you want to keep doing your slope, 1, 2, 3 every 1. 1, 2, 3 every 1. Equation. Again, I put 20 in for the y. So if 20 equals 8 plus 5 force x, I'm going to fraction best again. I'm going to multiply everything by 4. So I'm going to get 80 is equal to, and I multiply this by 4, 32. When I multiply 5 force by 4, the 4's will cancel, and I get 5x. I'm going to minus 32 from both sides. And so when I minus 32, I end up with 48. And then I'm going to divide both sides by 5. So I'm going to take 48 divided by 5, which is 9.6. So it's going to take her 9.6 seconds. Okay. So Leslie finished in 6.7. She was the winner. Kristen was in last place at 35 seconds. And then Evie finished at 9.6 seconds. Hopefully you find this helpful. Your homework is going to be very much like this worksheet, and be ready for a quiz on Friday on multiplying binomials.